Okay, this section is about shifting the graph of a function, left, right, and up, down. So given the graph of a function, y equals f of x, then here's another function, y equals f of x minus h, that plus k. It will be the same graph as before, but shifted left or right, up or down. Let's take, for example, y equals absolute value of x. Its graph is a V shape. If we add k outside, then we get y equals absolute value of x plus k. That shifts the graph up or down. Up if k is positive, down if k is negative. So here's y equals absolute value of x. Here's absolute value of x plus 1, shifted up 1 unit. This, I guess, is absolute value of, let's say, x and 1.5. This is y equals absolute value of x minus 1, shifted down 1 unit. Y equals absolute value of x minus 2 is shifted down 2 units. So f of x plus k shifts the graph up k units if k is positive, down if k is negative. Now, here instead of adding k outside the function, here we subtract h inside the function. And that shifts the graph left or right because it's delayed by h units. So if this is the graph of y equals f absolute value of x, then y equals absolute value of x minus 1 is 1 unit delayed. So it's this shifted, the same v shifted to the right 1 unit. Y equals absolute value of x minus 2 is shifted to the right 2 units. Y equals absolute value of x plus 1 is accelerated or preceded by 1, so it's shifted to the left, anti-delayed. Y equals absolute value of x plus 2 is the original v shape shifted left 2 units. So y equals f of x minus h shifts the graph right h units and up k units if h and k are positive, left and down if they're negative. So for example, if this is the graph of y equals f of x, then the graph of y equals f of x minus h plus k is moved right h units, up k units, like that. Now there's also multiplying by multiples inside and outside the function. Right now, I'll start out with negatives. If this is the graph of y equals f of x, then y equals minus f of x flips it up or down. It's a up-down flip through the x-axis. Y equals f of minus x flips it left or right through the y-axis. And if it's both, minus f of minus x, it flips to the y-axis and then flips to the x-axis. And that's the same as a rotation around the origin. We start with something and flip it left or right, up or down, then left or right. That's the same as a 180-degree rotation. So for example, all right, this is, here's a graph of a function they want to find. F of what value is f of negative 2 is what? Go left 2, down negative 4, there it is. F of 0, start x equals 0, it's 0. F of x is 4, for what value is it? 4, 1, 2, 3, 4, it goes to a height of 4. For this value of x, 2. F of what value of x is negative 2, look at the level negative 2, it meets the graph here at x equals negative 1. Here's the function x plus h cubed minus 2. What's its graph? Okay, we start with the x cubed graph like this. This plus 1 makes it happen 1 unit earlier, so left 1. This minus 2 pushes it down 2 units, so left 1, down 2, left 1, down 2. This point here called the inflection point, where it goes from cup down to cup up, is moved down to here, to negative 1 by 2. That's cup down left of it and cup up left of it, right of it. Here's graph y equals x minus 2 squared plus 4. Well, the x squared graph is this U-shaped. This x minus 2 delays it 2 units. This plus 4 moves it up 4 units. This bottom point, called the critical point, at 0 by 0, is moved right and up to 2 by 4, and the U-shape goes up from there. Here's g of x equals absolute value of x plus 3, that plus 5. Now here's a graph of absolute value of x, a V shape. This +3 moves it left, the graph left 3. It happens 3 units earlier. This +5 moves it up 5. So left 3 up 5. This sharp corner point at 0 by 0 is moved to -3 by 5. And the graph is like that from there. Here, we have absolute value of x minus the absolute value of x plus 5. Now, the minus flips it up or down. So instead of a V shape, you get an upside down V shape. This +5 shifts the graph left 5. So instead of going through this point at 0, 0, it goes through -5 by 0, and it's upside down V from there. Is this a function graph? No. Vertical line meets it twice. Is this a function graph here? Yes. Any vertical line will meet it but once. All right.